So I've had really good luck getting this solid state memory IO-4 card actually up and running. One issue I had was the UART over here failed in testing. It ran for a few hours and then just failed. And luckily I have a spare card like this one that I've mentioned before that's a little bit beat up, a little bit rough, and I just pulled a UART out of it and it worked. I had a strapping configuration issue that I've repaired here, and we'll look at the configurations I used. This card is fully emulating the Altair 8800 standard I/O device. You know, that dual serial card in the system, and it emulates it well. And the fact that it's a hardware emulation is really quite interesting. You know, looking at the date code of the original UART here, it's 1976. We've got other parts with date codes from 81. I believe this card was probably manufactured in 81. 80th week of 37. But, you know, I see, like I say, I see 81 here, although those may have been added later. 79, 79. 40th week of 80. It's just hard to say, but I guess it was manufactured 80, 81, so it's about 38 or 39 years old. Really good luck with it so far. We've talked about this briefly before. There's two UARTs with two serial outputs. You know, serial A over here and serial B over here. This is strapped to be TTY0 and this one TTY1. The configuration of the card for number of bits, parity, etc. is set on dip switches here, and those dip switches are hardwired to pins on the actual UART. The status lines for, you know, character waiting and buffer, ready to receive, are again hardwired pins, and they're jumpered here to a port so that the Altair can, you know, CPM or Altair can read that port and know the status of the UART. The jumper configuration here basically allowed me to jumper this to look like the status register and the actual Altair UARTs. So again, it's a hardware emulation. We set the port address down here. And then we've got the parallel section here with two parallel and output ports, the 8212s or 74412s, the port address for them. So really what I had to do here is we can jump onto the other photo here. This is updated from the last time we looked at the photo. I think I had the TBMT signal coming up to pin data 7 up here for some reason. It actually had to be configured as shown here. So the character ready and character to be read in the UART comes from the ODA pin on the onboard UART to, in this case, it'll be port 10 in hex, where it expects to find, you know, those bits. And the same thing for character, you know, transmit buffer's empty. So that mapped those down. Everybody's jumper to 9600 baud here. I had an issue initially where I hadn't tied to both grounds here. So, you know, I've tied to both grounds and picked up the EI out and EIA in. If we come back, you can probably see there's a wire link here now across the two grounds to the ground wire on the ribbon cable that goes out to the DB25 connectors. So really, it just took getting the strapping right, replacing the one failed UART, setting the port address. In this case, this is set to 00, you know, on, off, on, or 0001, 00, and then there's two bits down here to select, you know, what it's looking at. As far as CPM is concerned, it's, you know, it's getting TTY 0 status. Really, from the jumper configuration, actually we have, yeah, right here, it's getting the TT1 status from the jumper configuration we have here. In CPM, it actually initializes the original UARTs by doing writes to, you know, the port 10 and port 12. Those writes do nothing to this board. It doesn't matter because this is all basically hardwired. So let's go ahead and demonstrate it in action here. Let's get TerraTerm opened up. I want to get a second session opened. And I believe this one needs to go to COM 2 on my PC. Oh, Mr. Robot sneak peek popping up here. So this will be TTY0. It'll be the console. CPM should give us its, you know, its startup information here, and then we'll run a basic program to exercise the other UART. So I'm going to turn on the Altair here. Go ahead and reset it. Fire up the floppies. I'm going to do an examine of address FF00 hex, which is where the combined bootloader lives in our 1702 ROM board. Run CPM. And we can see CPMs come up totally normally here. So again, this card's acting, as a TTY 0 and 1 card, which is really pretty slick. I believe I have a basic program on here named SSM, maybe test 2, which should exercise the other UART over here. I hope that's the right one. Load SSM test 2 basic. Yeah, this will exercise the UART over here on for TTY1. 12 here hex is 18 in decimal. So if you look at the bit field, this would be 0001 1000. If I got that right, 8, 9, 10. So that's 16 plus 2 here. Yeah, for status, 16 plus 2 is 18. And then port 19 is the data port for this guy down here. This is just going to spit characters out to it. If a character comes in, it'll echo out the character we type over here. But let's go ahead and run this. Am I on the wrong? To check my cabling down here, I may be on the wrong serial port. Let me change this to COM3 and see if that's where the traffic is. Yeah, there's the traffic. I had the wrong COM port picked on my machine. So this is just outputting in a for loop here, an up count from a space to character 127. It's spitting it out right here to the UART that's driving that TTY port. And if I hit a character over here on the input, this will see it. The status here will change to an FF momentarily. It'll read the character and display it, and it'll scroll by. We can see that here where the status bit, the least significant bit down here, the character ready bit became a 1 because there was a character waiting in the buffer over here. I then, in the basic code, read that character in right here. There should be an import. Yeah, right here. So basically it says if the status became 255, or in this case that least significant bit became a 1, there's a character waiting. Read that character in, display it here in both hex and as a character itself. And we can see that again as I type over here. Characters will scroll by. So really there it is. I've exercised this replacement UART for quite some time. The original UART worked really well for a while, and then it started getting random character errors, and then it just became all the characters were in error. Trying to send characters back like we're demoing here didn't work, and the UART got really warm, so I'm pretty convinced that the original UART chip failed. So I really think with these 2 videos, we've completed the cleanup of this card. Where's the other photo? The card's in really good shape. There was a grounding strap here I removed. I need to remove the glue that was underneath it off there, or that maybe it's dead flux. This had been updated a little bit to the IEEE 696 S100 standard, where there should be an additional ground here. On the Altair bus, that isn't a ground, so I just went ahead and removed that. For a card that's nearly 40 years old, it's in really good shape. It's really clean. Besides the one failed UART, it works. So, pretty happy with this. It's a step forward in getting as vintage as I can have machine together. So, I guess really with that, I'll wrap this up, and we'll talk soon.